Hello everyone, welcome to today's lecture. In today's lecture, we will start practice questions based on area bounded by the curves. In the last session, we had done till question number 7. So in today's class, we will start with question number 8 and we will discuss till question number 14. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So let's start with question number 8, which says the curve y is equal to a root x plus bx passes through point 1, 2 and the area enclosed by the curve and the x-axis and the line x equal to 4 is basically 8 square units. Then we have to calculate a minus b. See, first, the hint of this question is, since point 1, 2 is passing through this curve, right? So you can get the equation of line by putting the values of 1 and 2, 1, 2 in place of x and y. So that will be equation 1 in terms of a and b. And after that, the area enclosed by the curve from curve and the x-axis and the line x equal to 4 is basically 8, right? So you can integrate y dx. You can find integration of y dx from 1 to 4, and you can is 1 to 4 and equate it with 10, equate it with 8. You can easily find another equation in terms of a and b, right? So you'll get two equations in terms of a and b, right? And you can easily calculate the value of a and b. Okay, so in this way you can try to approach this question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, as y is equal to a root x plus bx when x greater than equal to 0, at x equal to 1, y equal to 2, therefore by putting the values, you will get equation a plus b is equal to 2, equation 1. Now, area under the curve 0 to 4, a root x plus bx, a root x plus bx dx is equal to 8. Therefore, we will get the value of integration after putting the values 16a upon 3 plus 8b is equal to 8. So this was equation 1 and this is equation 2. Now on solving equation 1 and 2, you will get a is equal to 3 and b is equal to minus 1, right? And we have to find basically a minus b. So a minus b will be equal to 4. Clear? A minus b will be equal to 4. Option D is the right choice. Option D will be the right choice. Okay. Let's move to the next question, question number 9, which says, if y is equal to fx makes positive intercept of 2 and 1 units on x and y axis, on x and y coordinate axis, and encloses an area of 3 by 4 square unit with axis, then integration of 0 to 2 x f dash x dx is. So again, the hint of this question is, since we have a curve which is making intercepts, 2 and 1 unit on x and y axis, right? And the curve encloses an area of 3 by 4 square unit with the axis, right? So integration of fx dx on different limits will be equal to 3 by 4 square unit, and this can be easily calculated. You can use integration by parts, right? Or you can adjust this integration from a certain limit. Then you might get this as a result, right? So in this way, you try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay. Okay, let's move to the solution part C. Clearly, y is equal to fx passes through 2, 0 and 0, 2, right? Y equal to fx passes through 2, 0 and 0, 2 because it is making intercepts of 2 and 1 unit on x and y axis, right? Therefore, 0 is equal to f2 and 1 is equal to f0. Also, integration of 0 to 2 fx dx is equal to 3 by 4 given. Now, integration of 0 to 2 x f dash x dx. When we will use integration by parts, we will get x fx 0 to 2 minus integration of 0 to 2 fx dx. Therefore, integration of 0 to 2 x f dash x dx will be equal to 2f2 minus 0 f0 minus 3 by 4. Now f2 is 0. f2 is 0. Clear? So integration of 0 to 2 x f dash x dx is equal to 2 into 0 minus 0 into 1 minus 3 by 4 is basically minus 3 by 4. So answer should be minus 3 by 4. Got it? Answer is minus 3 by 4. I think option D is the right choice. Got it? Okay, let's move to the next question. Question number 10, which says that the area of the region in square units in the first quadrant bounded by the parabola y is equal to 9x square, the line x equal to 0, y equal to 1 and y equal to 4 is. So how can you approach this question? First, you will draw the curve y equal to 9x square, and after that you will draw the region, that is y equal to 1 and y equal to 4, and then you will try to integrate in terms of y, that is, since y is 9x square, therefore x will be root y upon 3. Therefore, you will integrate root y upon 3 dy from y equal to 1 to 4. Right? Then you will easily get the area of the curve between the interval y equal to 1 to 4. Right? So in this way, you can try to approach this question. Now you have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part 3. As we have discussed, this is the area. This is the curve, and y equal to 1 and y equal to 4 is this line. And we have to basically find the area of region in the first quadrant. That is, we have to find this area of shaded region, right? Between the lines x equal to 0, y equal to 1, this is x equal to 0, right? This is x equal to 0, and y equal to 1 and y equal to 4. Therefore, we can calculate, as we have discussed, x is basically root y upon 3, right? Therefore, integration of 1 to 4 root y upon 3 dy. So integration of root y will be 1 by 3 will be taken out because it is constant. So integration of root y will be y to the power 3 by 2 upon 3 by 2, 1 by 3, and limit is from 1 to 4, right? So after putting the limits, we will get integration as 2 by 9, 4 to the power 3 by 2 minus 1 to the power 3 by 2, which after solving we will get 2 by 9 into 7. 2 by 9 into 7. So answer will be 14 by 9. Answer will be 14 by 9, right? Got it? Answer will be 14 by 9. Okay, so I think option D is the right choice. Now let's move to the next question, question number 11, which says that the area bounded by the curve y is equal to ln x and the line y equal to 0 and y equal to ln 3 and x equal to 0 is equal to. Right. So see, we have to basically find y equal to ln x. So limits are given in terms of y. Right. Therefore, we will convert. We will take y. We will take x dy. We will take x dy. Integration of x dy. So x will be, if y is ln x, then x will be e to the power y. E to the power y, right? So we will have to find e to the power y dy integration from 0 to ln 3. Clear? This will be basically the area bounded by the curve. Okay, in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Required area will be 0 to log 3 x dy, as we have discussed, and x is basically e to the power y. Right, so required area will be 0 to log 3 e to the power y dy. So integration of e to the power y is basically e to the power y, right? So e to the power y limit is from 0 to log 3, right? So e to the power log 3 minus e to the power 0, and 3 minus 1 is equal to 2, right? So I think option D is the right choice. D is the right choice too. Okay, D is the right choice. Okay, let's move to the next question. Question number 12, which says that the area of the region bounded by the curve x is equal to y square, bounded by the curve ay square equal to x cube, the y axis and the line y equal to x, and y is equal to 2a is, right? Y is equal to 2a is. So again, the hint of this question is we are given a curve and we have to basically find area between y equal to a and y equal to t, 2. Right. So x will be equal to a to the power 1 by 3, y to the power 2 by 3, right? So we will integrate integration of x dy from y equal to a to 2, right? And x is equal to a to the power 2 by 3 and y to the a to the power 1 by 3 and y to the power 2 by 3. Then we will integrate integration of a to the power 1 by 3, y to the power 2 by 3 dy from a to 2a, right? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. C. Required area C. We have this curve ay square is equal to x cube. Ay square is equal to x cube. And the y-axis and the lines y is equal to a and y is equal to 2a. Y is equal to a and y equal to 2a. Therefore, required area will be area of BM and C. BM and C. Required area will be area BM and C. Therefore, area BM and C will be integration from a to 2a x dy. A to 2a x dy. Therefore, it will be equal to integration of a to 2a, a to the power 1 by 3, y to the power 2 by 3 dy. So we will take a to the power 1 by 3 out. So it will be a to the power 1 by 3 and integration of y to the power 2 by 3 dy will be y to the power 5 by 3 upon 5 by 3, which is 3 by 5 a to the power 1 by 3, and limit is from a to 2a, which after solving we will get 3a to the power 1 by 3 upon 5, 2a to the power 5 by 3, 2a to the power 5 by 3 minus a to the power 5 by 3. Clear? We can take a to the power 5 by 3 as common. So 3 by 5 a to the power 1 by 3 into 3 by 5 into a to the power 1 by 3 into a to the power 5 by 3 into 2 to the power 5 by 3 minus 1. Right? And after solving, we will get 3 by 5 a to the power 3 by 5 a square, 2 into 2 to the power 2 by 3 minus 1 square unit, right? So I think option A is the right choice. Got it? A is the right choice. Right? Okay, let's move to the next question. Question number 13, which says the area of the region bounded by y is equal to mod x minus 3 and y equal to 2 is. The area of region bounded by the curve y is equal to mod x minus 3 and y equal to 2 is. So see, in this question again we will draw the graph of y is equal to mod x minus 3 and by see in this curve you might need not to like integrate, because by using the graph of curve you can easily find and calculate the area of triangle that will be in the shaded region, right? So try to draw the curve and try to see whether we have to integrate, we have to find area from which point to which point, right? So you can easily be find area by using geometrical area, right? Okay. So in this way, you try to approach this question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. As we discussed, first we have to draw the curve y is equal to mod x minus 3. This is the graph of y equal to mod x minus 3, which is from 3 to 0. Now we have to basically find the area between the region y equal to mod x and y equal to 2. Y equal to 2. Clear? The curve y is equal to mod x minus 3 meet the line y equal to 2 at point C. These points are basically 1 and 5. X equal to 1 and 5. X equal to 1 and 5. Therefore, area of shaded region will be C. This perpendicular will be 2, and this base will be 5 minus 1, which is 4. Therefore, area of this triangle will be half into base into height. That is half into 2. Height is 2 and the base is 4. Half into 2 into 4, and 2 and 2 will cancel out. Therefore, area of the shaded region will be 4 square units, right? So you can easily see that you always don't need to like calculate the area by using integral. Sometimes you see first try to make the curve, right? And once you are not able to calculate the area by using geometrical form, then only you try to integrate, right? When generally it is a straight curve, we generally use the formula of areas of like different shapes. Here, the shape is triangle. Shape might be a square, rectangle, trapezium, mixed of the different figures, right? Mixture of different figures, right? So for the straight lines, we generally use area by using geometrical form, right? Okay. So I think answer is 4 square units. Okay. I think option D is the right choice because 4 is not given in the option. Okay. Let's move to the next question. Question number 14, which says that the area between the curve y is equal to 4 minus mod x and the x-axis. Y equal to 4 minus mod x and the x-axis. Again, you try to draw the curve of y is equal to 4 minus mod x. Right. Try to draw the curve of y equal to 4 mod x and see whether it is cutting x-axis on which points, and try to calculate the area by using geometrical calculations, right? By first you will see the geometry of the area distribution, and you will try the formula of different triangle or rectangle or trapezium, whatever the shape will be formed, right? So you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. When we will draw the graph of the curve y is equal to 4 minus mod x, 4 minus mod x, this will cut the x-axis at minus 4, 0 and 4, 0. Right. So the area will be the area of this shaded region, right? Shaded region, as base will be 4 plus 4, which is 8, and height will be 4. Therefore, area of the shaded portion will be half 1 by 2 into 8 into 4. Right. So 2 and cancel with 2. So 8 into 2 is 16 square units, right? 16 square units. So area will be 16 square units. Clear? This y is equal to this I have represented the function using piecewise. The function y is equal to 4 minus mod x using piecewise function, as in the different intervals of x. When x less than 0, y is equal to 4 plus x, and when x greater than 0, y is equal to 4 minus x, right? Right. So after all the calculations, we got on option L, answer as 16 square units. So I think option A is the right choice, 16 square unit, right? So in this way, we have tried to explain different types of questions based on area bounded by the curves. Hope you understood the concepts, how to apply the we use directly an analytical method or geometrical method, or when we usually integrate, right? When you will practice a lot of questions, you will easily understood how to apply the concepts, right? Hope you liked the lecture. Thank you so much.